Well, it's been an interesting couple of days. I hope you've enjoyed yourselves. I have. I come here with an interesting prehistory of working for this company. And I used to be the company's deniable source of information and a public target at the same time. There's nothing like working for a telco if you want to be shot at, have things thrown at you and be accused of everything. And the problem is that the complexity inside the telco world is far greater than you could imagine when you're on the outside. It's a huge machine, it's got a tremendous legacy, and it's got a lot of things to do. So what I thought I would do, rather than try and summarize these 2 days that have been a little bit chaotic, I would do something slightly different and pick on a few points. So first of all, in my view, God was a communications engineer. And the reasons are, he gave us three wonderful things: silicon, silica, and electromagnetic waves. Now, the great thing is that we got electromagnetic waves right because we discovered wireless and radio and got on with it. Silicon was used for transistors and integrated circuits. We got that right. The big mistake was we discovered copper before we realized what you could do with silica, which is make glass. Now we've discovered what we can do with silica, it changes the whole name of the game. So here's some prehistory that may surprise you from the 1970s and 80s. We're talking here pre-PC, personal computers, and pre-mobile phones. This is a diagram that I drew using a pen, a ruler, and using a typewriter. And it shows the migration of the BT network in the 70s from coax cable right the way down to the 1990s with 100 kilometers of single mode fiber at 1.5 micron. The thing to look at is the mean time between failure, because way back in the 70s, the mean time between failure on our transmission stuff was 0.4 of a year. You get down to single mode fiber, it slips out neatly to 100 years. Then you look at the equipment and you say, well, the old asynchronous stack, mean time between failure of 2 years, then you've got a synchronous stack 10 years. Guess what? When you get an optical stack in there, it suddenly jumps to 25 or 30 years. Ergo, you cannot afford to operate with this stuff. So quite smartly, we got to move on and decided that we'd deploy fiber in the long lines network. It took 6 years. The company went down from 242,000 to 110,000 in 6 years. No strike action, nothing in the newspapers, superbly managed. So, here we have it. Mean time between failure, different technologies, SDH and SONET. Remember those old-fashioned technologies? They're on the way out. And there was such a transformation and improvement that it was obvious that we should get into the local loop. And the calculation said we only needed 35,000 for the entire country. The entire company in the UK, 35,000 employees. Right. Now this is a very dim diagram because I recovered it from a foil. Remember those things? So I've done a rather brighter one. We figured out at that time that we could get rid of something like 6,500 switches in the UK by backhauling on fiber to central nodes. We only required 60 nodes in the whole of the UK where we had switches, which would now, of course, be routers. At this time, IP wasn't an everyday term. So we got the essence of what we needed to do. So there's only one question, and that is, given that I installed this into my home in 1986 and got it to cost in against copper in 1986, we built factories in Ipswich and Birmingham to manufacture the electronic and the photonic components and all the boxes. So how did we get it to cost in? Simple. Not by simple-minded upfront costing, but by whole life costing. And here it is. When you put fiber into the local net, you get rid of 50% of the faults. When you get your employees out of the network, because you don't have to have them rewiring the wire, you get rid of another 25% of the faults. When you remote route the fiber, it saves about 95% of the work that human beings are involved in. The fiber reach removes electronics. switch nodes and building stock is reduced by 90%. The OSS and BSS system and cost collapse. The energy costs reduced by over 50%. The staffing is reduced by over 80%. What a winner. No manager on this planet could get this wrong. Year on year, OPEX falls with every new cycle of new technology. You're onto a winner. And the projected cost of fibre into every home and office in the UK in the late 90s, only 15 billion. Oh, that's 3 years' profits in those days. Time to complete 10 years. So a spend of about £1.5 billion a year. Absolute no-brainer. So let's go and do it. What went wrong? Oh, a few things. Politics. The government were trying to educate everybody to the fact that we needed a deregulated market and we needed lots of competition. Unfortunately, we were the only company in the world that could do this, so they stopped us doing it. Regulation, they didn't like it either. The stock market, ooh, you're going to spend money. Never heard of this technology. Vested interest, all the guys working in the local copper needed this like they needed a hole in the head. They were going to be fired. The people, difficult to train enough people fast enough. Hey, there's no demand. Who's going to need 1 megabit to the home? It'll never happen. Okay, so stopped. That's not the only technology that did this. Just about every technology I've worked on has done this, but now Phil and the team are actually doing it. Hooray, I've been on the trial, it works. In 30 years, fibre has revolutionized everything. We would have no internet without fibre. And now there's a screaming need for fibre to the home and fibre to the office. It is the only way we're going to power industry in this 21st century. But the environment's changed. We're now in a dive to the bottom. We've gone from being telco to Tesco. We're in a commodity business. It is different. There are no more 22% profit margins. It's settling down to very low single-figure profit margins. So it's going to be tough. And what is a commodity? It's something that we actually find is plentiful, we need it, we don't value it, we're not prepared to pay for it. It's something we take for granted, and it always results in industry consolidation. There is tremendous turmoil out there. Watch AT&T, biggest telco in the world, also ran, and now it's going to be bought up and will be part of the biggest group in the world. The other thing that I think has changed during this period is a whole emphasis. It used to be about me, the supplier. You do what I say, you'll have a black one. It's now me, the customer. If you don't deliver the one I want, at the time I want, at the price I demand, you can go jump in the lake because I've got plenty of other suppliers. That's a big change out there in the market. So I didn't work on this technology, but I did work on all of these. And to my mind, it's quite remarkable that as a young engineer at this place, I was buying Winchester hard drives for $20,000 for a whole 20 megabytes. And now I can get a gigabyte at 40 pence. My son has built a 4 terabyte server, and I now have a personal ambition to own a petabyte of storage before I die. Don't ask me why, but my son assures me I need it. Oh, and by the way, I can afford it, apparently. Computing power's changed everything. More than I think we recognize, but it really has. So there's some disruptive forces. And these are serious. Everybody's and everything is getting connected. We are, each of us, quite disruptive in the way we work. So the question is, can we predict the future? No, but we can build it. Centralized networks die. Well, I think this is a relative thing. It's because more and more of the intelligence is going to the periphery of the network. The periphery is getting smarter, the core is getting far dumber. And we need to massively simplify OSS, BSS, billing, everything. We need to poll for data, i.e. managing networks is going to look much more like using Google than a mighty Wurlitzer. We're going to have to use agents and not wires. And we're going to have to offload a lot more to get the customers to do the work. And the customers will be pleased to do the work. They really will. So here's the dream. I want to wander around this planet with my devices and get connected without having to go through some encyclopedic process of doing lots of changes of preferences and stuff. I just want it to work. I'm an engineer, I know it can be done, and as a user, I get irritated every time I have to start fiddling. We can do this. The question is, how well are we doing? Well, here is an experiment. I have now found that in 2.5 years, I've not connected my laptop to a phone line, and in the last 1.5 years, I've not connected it to my mobile phone. Wi-Fi is everywhere. 60% of the time, it's within a city block of where I am. 95% it's within 3 city blocks, 100% of the time, 4 city blocks. I have not, wherever I've traveled in the last 1.5 years, not been able to find Wi-Fi. It's there. Here's the trick. You're in the street, you wonder where a Wi-Fi node is, wait until you see somebody carrying coffee. Backtrack on them, find the coffee shop, you're online. It's a dream. Interesting statistics. 35% of the sites I find are absolutely free, 60% are real low cost and I don't care, and 55% are rip-off hotels, who I harangue and either get them to give it me for free or I don't stay there again. Mountain View. My office is just up here on Moffett Field. Mountain View, thank goodness Google. This is a metropolitan network. The whole of the valley has just announced from top to bottom, every city in the valley is going to roll out such a network. This is fairly dense Wi-Fi. This is going to change the nature of the business environment. Every day you and I get in contact with, carry, buy, use, play with more things. There are now more new mobile phones introduced into the market every single week than there were electronic products in the whole year of 1956. Kind of incredible. I buy my technology by the color of the knobs. I have no idea what I'm buying. I can't figure it out. I go and ask other people if they've got one, do they like it, and then I buy one the same. It is just nothing. Social networks. This didn't happen 30, 20, or even 15 years ago. This is a network of children at school. This is kids who are networking by laptop, by telephone, and by mobile phone. The whole nature of network is changing. So we now have a tricky subject called strange attractors. This stuff brings down networks every day. This stuff is an absolute menace. In every city on the planet, you will find somewhere a major international conference every week. First thing in the morning, everybody's in there, phones are off by and large, everybody's listening to the speaker, 10 o'clock, coffee arrives, 300 phones come out, everybody tries to make a call, network collapses. To service that kind of chaos, we're going to have to build new kinds of networks with new kinds of technology. Because what is happening is we've gone from the averaging effect of random telephone calls to the peaky effect of the internet and our correlated activities caused by coffee, meetings, and a need for communication at the same time. So the PSTN, the old telephone network, had a mean peak to mean traffic ratio of about 4:1. The mobile net is about 50:1. The internet can be 500 to 1,000:1. That's like the whole of Ipswich this afternoon, the entire population, decide to go down Heathrow to fly to New York this evening. I don't think so. But we've got to find a way of coping with that kind of rush. This, I think, is going to be a good trick for the network operators to actually categorize these kinds of activities. Life critical is interesting. If a surgeon is performing a remote operation on a human being using telepresence and the network goes down, guess who they're going to take to court? So we've got to think seriously about how we manage the network information. We had a discussion yesterday and somebody said there's not enough spectrum. Let me just disabuse people of that fact. This is the North American spectrum chart, and it's always drawn like this. It's lovely and colourful, and it gives the impression of total use. The reality is it's mostly unused. And in the city of Chicago, in a recent study by the IIT, they found that less than 17% of the spectrum from DC to 30 gigahertz was being used in the city of Chicago. Hey, in Suffolk, we got a lot of unused spectrum. So what can we do? We've got FM, TV, mobile, optical, and Wi-Fi. Then there's a huge opportunity space from about 30 gigs up to 300. Just recently, IBM Zurich got a supercooled chip to switch at 500 gigahertz. At room temperature, it switches at 350 gigahertz, and we've got systems being developed at 60, 90, and 180 gigahertz. The sensors on the rear bumper or fender of your car operate around 60 or 70 gigahertz. They cost about $1. So there's an existence theorem that says we could go up there. When you, I'm just looking at the audience, there's a lot of people here who can remember what radio was, and it was things like Maxwell's equations and antennas and stuff. Now, for modern engineers, radio is protocols. And I know that radio is difficult, and you get scattering and reflection and interference. But hey, when you throw sheer computing power at it, you can take the scatter and you can turn it to your advantage. You can use multipath to increase the throughput. You can actually cancel out interference. And so the computing power is turning radio systems into black box. I am staggered that I can sit in here with 20 people using laptops, using Wi-Fi, and we don't have any interference problems. It just works. Brilliant. When I was younger, it would never have worked. But now, because it's frequency agile, it adjusts the power to use just enough. It selects the closest base station, and those kinds of tricks. It's changed the nature of wireless. This is going to hurtle straight down into the home. Sony Corporation will soon be launching a whole raft of new products that have got 60 gig radio instead of wires. So the TV, the projector, the surround sound system, the server, all connected by 60 gig radio. The server will have Wi-Fi and it will have Bluetooth. It will connect into the broadband network, and so suddenly you can use your mobile phone into your domestic entertainment system to make a phone call using voice over IP. Ouch. And it's not going to stop there. It's just going to roll, because once the consumer products guys get into it, the name of the game totally changes. Perception. There's Gary here. I'm going to pick on Gary's daughter. Gary and I have known each other for a long while, and like you, our perception of a network is things with wires. Gary's daughter has a laptop. She's never connected the laptop to anything using a piece of wire. In her home, she's got Wi-Fi. In her school, she's got Wi-Fi. And thanks to Gary, who works for BT, they've got Wi-Fi in the car into the 3G network. So Gary's daughter's perception of a network is some kind of cloud. And actually, I think that's the right kind of perception. You just pluck it out of the ether somehow. RFID, people tend to think about retail, but it's going to hit logistics. The average truck loading of trucks in North America is only 22%. In the UK, it's 17%. Mainland Europe's only about 20%. If we could aggregate truck loadings, we could take 4 out of 5 trucks off the road. As gas prices go up, that's going to get interesting. How do you do that? By having RFID on everything in the truck and on the truck and the container that goes shipboard. There is $2 trillion a year wasted on the logistics of shifting stuff. So when I look at business, I look at where the numbers are, and the numbers, the big ones, are in logistics, and RFID is going to change a lot of things. Sensors in mobile phones are going to become a really big deal. Has anybody got a clamshell phone? Anybody got? No. I've left. Can I just borrow your clamshell phone a moment? Thank you. I just in Washington saw a wonderful demonstration. You have to imagine a clamshell phone with a compass inside and an accelerometer and GPS. So you study in Washington, and there's the Washington Monument, and it says Washington Monument. And like, if I get it to do it, you go like that, and it says the White House. And the reason is, it knows where it is, it knows where it's pointing. And when you do that, the accelerometer says, tell me what's in that direction. And you can set, by calibration, 100 meters, a kilometer away. Magic. That device now becomes a pointer instead of just a phone. But when you think of things like pollution, when you think of things like identity, terrorism, and everything else, the mobile phone becomes a very powerful device. So, in my book, we can deliver an infinity of bandwidth to almost any location. All the old limiters have gone. Wireless density will accelerate, but the good news is it's going to mean even more fiber. The only way we can cook this coffee problem is to drop into here a lot of very small cells. When you go up above 30 gigs, you find the atmospheric absorption peaks limit the distance you can transmit, and you finish up with signals that won't penetrate the walls and won't go out of the room. So it means we can actually sort the problem by putting these cells in. And because of the entertainment industry, because of the retail industry, we're going to get these cells for virtually free. We need to think different. I think if you were last night at the dinner and you saw that laptop, it had to make you change your view of a few things. I mean, my instant reaction was, yes, please, I'll have one of those because it'll probably do just about as much as I want, and it gets rid of all the bloatware and it changes things significantly. The thing that interests me is that the young people are not only tech-aware and capable, they don't care about digital rights management. All the young men I know that are 18 eat nails for breakfast. They don't care about corporate lawyers, they don't care about telcos, they don't care about my wallet, they just go do stuff. And best of all, they're content producers. We intend to ship less lines of code on each successive upgrade. Yes! Wouldn't I love that? I just loaded up a new laptop and it's just eaten an extra 15 gigabytes for no obvious advantage or change in operating. You know, boy. Mozilla. They will not put features on, they only take features off. The biggest problems we face, not technology, not operational, the business model and thinking is very often wrong. People find it very hard to change. It's really tough transforming companies. Finally, survival ain't mandatory. Any technology or company is fair game. It really is a fight to the death. In every industry, we've got very little time, we've got to get a move on, and we've got to get the job done. It's harder if you're in a legacy industry. It's really, really difficult. But I think there's a huge opportunity. I happen to think Phil and the guys are absolutely on the right track. I'm not really upset that it's taking 25